In this video, we're going to take a look at special right triangles. Now, this is something that is kind of a shortcut because for the majority of the problems you're going to look at, you would be able to use either Pythagorean theorem or trig to find the missing sides or missing angles, but if you recognize the 45, 45, 90 and the 30, 60, 90 right triangles, then you can save yourself a little bit of time if you remember the patterns. So with the special right triangles, there's really two that we're going to look at this year. And also, if you're moving on to Algebra 2 next year, these are going to, again, be things that are going to help you with the material in that course. So a 45, 45, 90 special right triangle is basically talking about the angles in that triangle. So it's a right triangle, so it has to have a 90-degree angle. And then it has to have two other angles that are both 45 degrees. And now, because we have two angles that are the same, that also means that we're going to have two sides that are the same, which actually makes this an isosceles right triangle. So in this picture, we would have two sides that are the same, and those two sides are going to be the legs. And now I don't know how long those are, so I'm going to just label them x. And now what happens here is the hypotenuse is always going to be whatever the length of the legs happens to be, times the square root of 2. Now, if we think about that, if I had a right triangle, and I know it's isosceles, and I know that the legs are 3, I could go through and I could use Pythagorean theorem. So leg squared plus leg squared equals the hypotenuse squared. And if I go through and solve that, I get 9 plus 9 equals x squared, so 18 is equal to x squared, and then I have to take the square root. And if I simplify the square root of 18, I get 9 times 2. 9 is a perfect square, and so it turns out to be 3 times the square root of 2 for my x value. So again, no matter what the length of the legs are on your isosceles right triangle, the hypotenuse is going to be that length times the square root of 2. So here's kind of how this works. If you remember the shortcut, if you remember that the hypotenuse is just the length of the legs times the square root of 2, if you're given the leg and you want to find the hypotenuse, you multiply by the square root of 2. But if you're going from the hypotenuse to a leg, then you divide by the square root of 2. All right, so if we take a look at a couple, in this case we have a 45, 45, 90 right triangle. We're given the length of one leg, which means the other leg is the same thing. And then just using the pattern, my hypotenuse is just going to be 8 times the square root of 2. All right, now in the second example, we know the hypotenuse and we're trying to find the length of the leg. So if we know the hypotenuse and we're trying to find the length of the leg, we're going to divide by the square root of 2. So if we have 3 square root 2 and we divide by the square root of 2, we're going to be left with 3. So the length of each leg on that isosceles right triangle would be 3. And then in the next one, we have the hypotenuse again. If you see your 45, 45, 90 right triangle, it's basically half of that square. And the hypotenuse is 10, and we're trying to find the length of the leg. So what we want to do is take the length of the hypotenuse and divide by the square root of 2. All right, so on the bottom, see if you can try those last three, numbers 4, 5, and 6, and see if you can come up with the value of x for each of those. The second special right triangle that we're going to talk about is a 30, 60, 90 right triangle. So again, it's a right triangle, so it has that 90-degree angle. And then the other two angles are 30 degrees and 60 degrees. So the smaller angle is 30 degrees, and the bigger of those two is going to be 60 degrees. And now in this right triangle, we have a short side, and remember the shortest side of a triangle is always across from the smallest angle. So if this is our smallest angle, the shortest side is going to be across from it. The medium side is always across from the medium-sized angle, so the medium side would be this side over here. And the longest side is always across from the biggest angle. In this case, our right angle is the biggest side, so this would be our longest side, which is also the hypotenuse. Okay, so with the 30, 60, 90 right triangle, the shortest side is kind of what I call your magic number. The short side is the side that you want to try to find. So I'm going to call that x. And the reason that you want to find that side is because you can get the other two just by knowing that one length. So if I know that the short side is x, my hypotenuse is always going to be double or 2 times the short side. And my medium side is going to be whatever the short side is times the square root of 3. All right? Now, basically, what you want to try to do, whether you're given the hypotenuse, the short side, or the medium side, is somehow try to find that value of x. Once you know the value of x, once you know the short side, then it's pretty easy to find the hypotenuse, just double. And it's pretty easy to find the medium side, it's just times the square root of 3. Okay. Now, if they give you the hypotenuse, to find the short side, you would just cut it in half. And if they give you the medium side, to find it, you would just divide by the square root of 3. Okay. Now, tricks to remember the patterns. With a 45, 45, 90 right triangle, there's 2 sides that are equal, 2 angles that are equal, and that's the one where you use the square root of 2. In the 30, 60, 90 right triangle, the 30 is my kind of hint that I'm going to use the square root of 3. So just if you're looking for a way to keep those straight. All right, so if we take a look at this first example, I need to find both x and y, so I need to find the hypotenuse and the medium side, and I'm given the short. So this is my short side, this is my medium side, that's my hypotenuse. So the first thing I want to do is try to find the length of the short side, which in this case I already know it's 1/2. So if that length is 1/2, the hypotenuse is going to be double that. If I double 1/2, I get 1. And then my medium side is going to be the short side times the square root of 3. So in this case, that would be 1/2 times the square root of 3. All right. In the second example, this time we have the 60-degree angle labeled, we have the 90-degree angle labeled, so this one has to be 30 because they all have to add up to 180. And so if this is my small angle, the side across from it is the short side. The medium side is across from the 60-degree angle, and the hypotenuse is across from the 90-degree angle. So again, I want to try to find my short side, which in this case it's 8. So then my hypotenuse is going to be double that, and my medium side is going to be that number times the square root of 3. All right, in the third one, this time we're given the hypotenuse, and we don't know the short side, but remember that the hypotenuse is double the short side, so if the hypotenuse is 11, the short side is going to be 5.5. And then the medium side is whatever the short side is times the square root of 3. All right, so again, go ahead and see if you can try those 3 on the bottom and see what you come up with for those. And tomorrow in class, I'll give you a little sheet for your notebook that will kind of walk you through how to take a side and find another side based on that. But again, these are really meant to be shortcuts. You can use trig for almost all of them. You could use Pythagorean theorem for a few of them, but if you start to recognize your 30, 60, 90 and your 45, 45, 90 right triangles, then it's just going to help you speed things up